So let's do a little bit of practice dividing and following those steps. And I have them each on a separate page just to give you lots of room, just to let you know, like, so you don't feel that you have to get all of this in a small amount of space. These problems are best if you spread it out a little bit and give yourself some room to work. There were no placeholders that I needed to put in, so I'm going to start off with the second step, which is focus on the first. What is x to the fourth divided by x squared, and I get x squared. I now multiply that x squared by everything in the divisor, and I get x to the fourth minus 2x cubed minus 5x squared. Notice I'm always lining up my like terms. Now I go to subtract, which means I change my signs. Minus, plus, plus. I get 3x cubed, because now that I change my signs, I can simply add minus 14x squared, carry down the x. And now I repeat my steps. Focus on the first. 3x cubed divided by x squared is 3x. Multiply the 3x by everything here. I get 3x cubed minus 6x squared minus 15x. I'm going to subtract, so I have to change all of my signs. And now I can add up since I changed my signs. Negative 8x squared plus 16x plus 40. Repeat my steps. Focus on the first. Negative 8x squared times x squared. Divided by x squared is negative 8. Now I'm going to multiply, and I get negative 8x squared plus 16x plus 40. Love when this happens. When I change all these signs and I add up, I'm going to get a remainder of 0. And you can check and make sure your answer is correct if you want to by multiplying it back out, and there's no remainder to add. Now I have to be honest that when I multiply a trinomial times a trinomial, I like to use a table. And this is just for me checking my work. And then I multiply. And the nice thing about the table is all the like terms end up on the diagonal. These are on the diagonal. Diagonal. So my final answer is x to the fourth plus x cubed, negative 8 and negative 6. It's negative 14 minus 5 is negative 19. 16x minus 15x is 1x. And it checks out. So I can have confidence. Again, I think this is the easiest way when you're multiplying a trinomial times a trinomial.